Initializers. Initializers were touched upon in the last lectures, but we will go into more depth here. So for built-in types, you must initialize a variable before you use it. So for custom types, it is possible for the type to define a default value, but there are some uses in doing this, which will be covered in next lecture, which in next chapters, in which chapter? Yeah, in classes chapter of this Oxley Udemy course. So in all versions of C++, there are three ways to initialize a built-in type. The first here, three ways to initialize built-in type. The first is assignment, which I will explain all of this. Assignment, function, syntax, or calling a constructor. So here, now let's try firstly try with assignment, then function, then syntax, and then call a. Actually, it's a 4 ways, so I'm sorry for it. It's a 4 ways for calling initializers. So in C+11, another way to initialize variables was introduced, construction through a list initializer. So there are 4 types here, as I said. So let's firstly create our code and write our codes and use 4 initializers here. Include standard deal here just for putting it here. So integer, actually we didn't need here, I just wrote it. Integer e here, integer g equals integer 2, which I will, yeah, it shows like pretty strange, but I will explain all of this. Don't worry. Integer key here. Actually, let's make this e, b, c. Integer c 3 or like this 3, and then integer m 4, integer d 4. So as you can see here, we initialized 4 variables to 4 integers. So the first of these 3 is the clearest types. So it shows using an easy to understand syntax that the variable is being initialized to a value. So the second example here, initialize a variable by calling the type as if it is a function. So as you can see, the second is a function, calling it by function. And the third example calls the constructor of the integer type. So this is a typical way to initialize custom types. So it's best to reserve the syntax just for custom types. So, and the fourth here, as you can see here, syntax is new. Here, actually, let me write it here. New to C++. So this is the kind of new to C++. It actually came with C++11 and initializes the variable using an initialized list between the curly braces here, as you can see here. Just to confuse things slightly, you can also initialize a built-in type using the same syntax as an assignment to a single item list. For example, integer e here equals equal operator here and 5, like this. So you can assign this operator like this too. So now I want to print these variables. Just in case to show that these variables works and you can print these values to screen. So let's printf. Okay, here. So decimal, new line, decimal, new line, decimal, and new line. decimal, new line lastly. Actually, let's add decimal here. Actually, same with D. Let's add here. And new variable 1 2 3 4 5 actually, and then add these variables e equals b equals c equals equality, d equality, and e equality here, d, and then e b c d e here, and actually I forgot to write main function, integer main here, and then integer. So actually in C-line, the writing these things is pretty easy. So it, as you can see here, it added one tab between this last line automatically. So now let's print our function. Actually, take this variables to main function here. Oops, why did there we go? Okay, take this to main function and compile and run our application. So as you can see here, we initialize with the first type assignment type and print it to console here, command line, and then we did the function b2, c3, d4, and these are the same actually with syntax calling a constructor type, which is a kind of new to C++ language. And I'm going to show you another thing. So just initializing the arrays here. So actually initializing arrays, initializing, actually let's printf initializing types, initializing, yeah, types, and then add just printf initialize arrays, and let's create our array. So this is a really confusing things. So the type here, the type e here is an integer but not an array. So as you know, we can write arrays like this. For example, integer birth years, for example, birth years, and then for example 11, for example, like this. We can with this curly braces we always did just creating array things, as you can see, but here we're assigning something, just a one variable to integers. So this is kind of confusing, I know. So just to confuse things slightly, you can also initialize a built-in type using the same syntax here as an assignment to a single item list. So recall that in the last lecture we created an array with the birth dates, and I did this. I wrote this code again. So this creates an array of 4 integers. So the type of each item is an integer, as you can see here, but the type of the array variable is integer pointer here, integer asterisk. So the variable points to memory that holds 4 integers. So similarly, you can initialize, also initialize a variable to be an array of one of them. For example, integer John, and for example John, for example this writer John's birthday, 1988, and as you can see here we did create just a single array, so we can use it as the just usual integer here. So this is exactly the same initialization code that C++11 C++11 allows to initialize a single integer. In addition, the same syntax is used to initialize instances of record types, as you know, structs here. So adding another level of potential confusion about what syntax means. So it's best to avoid using the curly braces for variable initialization and use it exclusively for initializing lists. So just avoid this. I just wanted to show you that C++11 has this feature. So, however, there are advantages of this syntax for casting, as explained shortly. So, the curly brace syntax can use to provide the initial values for any of the collection classes in C++ standard library.